Hello, algebra. So we are looking here at lesson 3.4, which is graphing linear equations in standard form. We looked at function notation just the other day, so now we're going to look at, well, what if we have something that's not y equals mx plus b, or in that case, f of x equals mx plus b. So horizontal lines. I just want you to know right now, horizontal lines are where we have y equals some number. All right, y equals some number. Those are horizontal lines. Another way of saying that is that they have a slope of 0. Right? They've got a slope of 0. So I've got a line right here. I've graphed it. I could pick out a point like this one. That point is going to be 0b, right? Or I could pick out this one. That point's going to be at 0b, whatever b is. B is just some number, right? This one over here could be 5 and b, and then 100 and b. So what we're noticing here is that no matter what the x is, the y is always the same. Right? That's a horizontal line. The y is always the same. Slope is 0. All means the same thing. So for a vertical line has an x equals some number. All right, and we call that number a, but it's an x equals some number. And so if I just pick out some points here, we've got this point. So that would be at a 0. Up here would be at a, let's just say that's 5. Or we could have an A and 100. So in this case, our x coordinate is always the same, right? Our x coordinate never changes, the y's do. That's a vertical line. Remember, these ones have a slope that is undefined. All right, undefined. And I know it's a little off the side. I'm going to zoom this out a little bit. There we go. So if we take a look down here, we want to graph the linear equation y equals negative 2.5. All right, negative 2.5. When we go to graph that, this is a y equals. Y equals are horizontals, right? They're horizontal. So I'm going to find where y is negative 2.5, 1, 2.5. So it's going to be right there. And then I'm going to draw a nice horizontal line. All right, and that's the graph of it. So let's take a look at this one. This is an x equals 5. X equals, that's going to be a vertical. So I want to find where x equals 5. Well, 1, 2, 3, 4, 5. And now I'm going to do a vertical line. All right, there's my nice vertical line. Something like that. So let's take a look at our next page. So for this one, we want to know how many points do we need? Ooh, too high. There we go. How many points do we need to make a line? We need 2. We need 2 points. So the equation, the standard form. I don't know where my brain went. It just blanked on me. All right, the standard form of linear equation is ax plus by equals c. All right, a, b, and c are real numbers, and a and b are both not 0. All right, so for our first one here, we have the x-intercept, where it crosses the x and y axis. So the x-intercept, all right, we want to find it for when it equals 0. For when y equals 0, we get the x-intercept. So when we have ax plus by equals c, we want to plug in 0 for y and then see what x equals. So we plug in 0 for y. So it'd be ax plus b0 equals c. And then we solve it from there. So this whole thing basically disappears, right? So that's really what you're solving. The x-axis, or the x-intercept, I should say, is going to be, there we go. It's going to be right here. It's where the line touches the x-axis. It's going to be at some point a0. This a and this a are not the same, okay? If it makes it better, change this into like a z or something, all right? It's just some number. So then the y-intercept, draw my same little graph. The y-intercept is where the line and the y-axis touch. So right here, and that's going to be at b and 0. Ooh, 0 and B. Dyslexia. There we go. And so this is where we have ax plus by equals c, not 0, c. So this would be a times 0 plus by equals c. All right, so it's something like that. So we're going to find the intercepts and then use them to graph. So I'm going to start with finding the x-intercept. All right, so we've got 3x plus 4y equals 12. To find the x-intercept, I plug in 0 for y. So we have 3x plus 4 times 0 equals 12. Well, this whole thing becomes 0. So this becomes 3x plus 0 equals 12, which is the same as just 3x equals 12. I need to get x by itself, so I divide by 3 on both sides. That means x equals 4. So my x-intercept is going to be at 4, 0. So I'm going to plot that 1, 2, 3, 4, 0. So now to find our y-intercept, we have 3x plus 4y equals 12. I need to plug in 0 for my x. So we have 3 times 0 plus 4y equals 12. So that's really 0 plus 4y. Well, that's really just 4y equals 12. Divide both sides by 4. We have a y equals 3. So that means my y-intercept is going to be at 0, 3. 1, 2, 3. So now that I have both those points, I need my ruler. Always use a ruler or some other straight edge, okay? And I'm going to connect these. Go edge to edge when you graph, all right? Go edge to edge, and then we want to have arrows on the end, all right? Because it does keep going forever and ever in both directions. This up here would be a positive 10. This would be a negative 10. This would be a positive 10. This would be a negative 10. It's really good to get in the habit of labeling your axes, all right? I did not do a super great job of that because I was feeling a little rushed at the moment, and I apologize for that. So that is how we graph. We've got our y-intercept and our x-intercept. 2 points, we've graphed it. Here's a couple more for you to try. I want you to actually try graphing them, okay? So if you don't have these printed, get on Kami, try it. It's really, really extremely important. So try those out.